How Noah's Ark was built. What ancient engineering made the giant ark possible. You've heard a great deal about Noah's Ark, but have you ever wondered how it was actually built? Where did the materials come from? How was it designed, and how could ancient people create a structure that far exceeded the limits of their time? Imagine a vessel nearly 140 meters long, equivalent to 4 football fields, laid end to end 3 stories high. Standing like an apartment building in the middle of a dry valley, large enough to hold thousands of living creatures at once. What makes this truly shocking is that it was built before steel existed, before machines, before engineers. The Bible gives us the dimensions but remains completely silent about the method. So, which ancient techniques turned an apparently impossible command into reality? This video will uncover that answer. And if you want to continue exploring the Bible through a technical and scientific lens that few ever discuss, subscribe now, because the forgotten stories are always in the next video. The ability of ancient people to fell massive trees was not the result of extraordinary strength, but of how well they understood wood. Without steel, tools were no longer the deciding factor. A bronze axe, carefully sharpened with stone, was sharp enough for continuous work, slower, yes, but precise enough to control every strike and prevent cracks from forming in the trunk from the very beginning. Trees were never cut at random. 2 men worked in turns, maintaining a steady rhythm to conserve energy and protect the axe edge. But the critical knowledge is something modern thinking often overlooks. Ancient builders clearly distinguished between living wood and dead wood. Freshly cut timber contains high moisture, and if used immediately, it will warp or crack under heavy load. That is why wood had to be air-dried and naturally cured before it could be used. They also studied the grain and cutting direction, because even a small mistake could weaken an entire beam. This was not labor driven by muscle alone, but craftsmanship built on patience and generations of accumulated experience. And once the timber had been properly prepared, a much larger challenge emerged. How do you move logs that weigh several tons? Each cutting the trees was only the first step. The real challenge began when those multi-ton logs lay motionless on the ground. No wheels, no cranes, no engines. From a modern perspective, this is where everything should have stopped. But ancient builders did not try to defeat physics, they worked with it. They placed smaller logs beneath the massive trunk, creating wooden rollers that transformed dragging friction into rolling friction. Instantly, what once seemed immovable began to move. No superhuman strength was required, only force applied at the right place in the right rhythm. This simplicity did not reduce effectiveness. It made the movement of enormous loads possible using human strength alone. But rollers only worked if the path was prepared. Stones were removed, the ground was leveled, and dangerous slopes were corrected in advance. A single overlooked rock could turn a rolling log into a deadly threat. Nothing was left to chance. This same principle allowed the Egyptians to erect colossal stone statues and transport the massive stones of Stonehenge. No wheels, no advanced technology, just an understanding of friction weight and respect for natural laws. And once the final timbers reached their destination, an even greater problem appeared. How could they be joined together without iron nails? This is where many people are most surprised. Noah's Ark required almost no iron nails at all. What sounds like a limitation was in fact a brilliant choice. Instead of driving metal into wood, ancient builders used mortise and tenon joints, precisely cut connections that locked beams tightly together. When fitted correctly, the structure behaved as a single unified mass, capable of bearing far greater loads. To reinforce these joints, they drove hardwood pegs through them. And here is the key detail: wood works with wood. In water and humidity, wood expands evenly, tightening the joints over time. Iron nails, by contrast, corrode, expand unevenly, and slowly split the wood from within. That is why in water, proper wooden joinery can be more durable than metal. This was not a temporary solution, but the foundation of ancient shipbuilding for thousands of years. And once the joints were secure, another life or death question emerged. How could rigid beams be bent into the curved shape of a ship's hull without breaking? Without bending wood, Noah's Ark would have been nothing more than a massive wooden box, heavy, unstable, and easily destroyed by waves. Wood is naturally rigid, and forcing it to bend with brute strength would almost certainly cause fractures. But ancient builders did not fight the wood. They changed it. The key was heat and time. When wood was gradually heated with steam, its internal fibers softened and became flexible. At that point, the wood no longer resisted bending. It was placed into wooden frames, slowly shaped into the desired curve, and then allowed to cool. When the heat dissipated, the wood hardened again, retaining its new shape. This was not speculation. The Vikings used this technique to build ships capable of crossing the stormy North Atlantic, and Mediterranean civilizations had applied it for centuries before them. Noah did not need modern technology. He needed to understand one principle: once wood could be bent, the next challenge was no longer shape, but ensuring the entire structure would not fail under forces coming from every direction. A massive ship must first survive itself before it can survive the water. Waves do not strike from a single direction, they twist, push bend, and torque the hull all at once. If beams are joined only in straight parallel lines, deformation is inevitable. Ancient builders understood this and chose a solution so simple that many today overlook it: the triangle. By reinforcing beams diagonally to form repeating triangular shapes, force was no longer concentrated at a single weak point. It was distributed throughout the entire frame. The remarkable property of a triangle is this: it is the only shape that cannot change form unless one of its sides breaks. You can push, pull, or compress it, the shape remains intact. Because of this network of diagonal bracing, the hull was no longer a collection of separate beams. It became one unified structure capable of withstanding violent motion over long periods of time. No complex mathematics, no modern formulas, just a clear understanding of basic geometry applied consistently. And it was precisely this simplicity that gave Noah's Ark its extraordinary strength. When you look back at the entire process, one truth becomes undeniable. Noah's Ark was not built by magic, but by deep understanding of nature. Ancient people lacked modern machinery, but they understood wood force geometry, and most importantly, how to work with materials rather than against them. Faith gave them the reason to begin. Engineering gave them the ability to finish. Perhaps the most thought-provoking lesson is this: many techniques that once created the greatest structures in human history are now dismissed simply because they seem too simple. Yet when applied correctly, that simplicity produces remarkable durability. If these techniques surprised you, leave a comment and tell me which part amazed you the most. And if you want to go further in the next video, we will step inside the Ark itself to explore challenges even more severe.